Hello everyone and welcome back. So now we're going to do a little bit harder problem. It says group problem solving. If you have a friend, do it together. Okay, so how's it work? What are we looking at? Well, let's find out. So, I went too far. What we have here is we have a screw eye right here, and we're applying some forces to it. Force 1 and force 2. Now there are a whole bunch of angles here. So there are actually 5 angles total shown for this. So that's kind of crazy. And what I want to know is the magnitude and the coordinate direction angles of the resultant force. Ooh, the coordinate direction angles. What is that talking about? I mean, those angle cosines I talked about, those angles that go directly from the vector to the axis, that's what it's asking for. Like, so we finally get some experience with that. We get a lot of experience with it because actually, one of our vectors, that's what's given here. You see how I have 3 angles given in this problem, or for this vector. One angle goes directly to the y-axis, one angle goes directly to the z, and one angle goes directly to the x. I have a second vector right here, which is not direction angles. You see a bunch of angles, but it's not the same thing. This right here is a projection. And so what you're going to do is you're going to break up a 3-dimensional vector into 2 two-dimensional triangles, okay? You're going to solve for this triangle first. And once you've done that, you're going to solve for this triangle right here. Okay? So remember that. Now, what's your plan? Well, you're going to use geometry and my head to get out of the way to break up F1 and F2 into their Cartesian vector form. You're going to add them together, and then you're going to determine the magnitude and angles of alpha, beta, and gamma, which are the Cartesian the coordinate direction angles after you do that. Okay, so you're supposed to go try this on your own. This is a harder problem. I'm going to give you about 15 minutes. In about 15 minutes, I'm going to count to 3, so I'm expecting you to pause and then go try it on your own. So, 1, 2, 3. Okay, hopefully you paused. Hopefully you went and did it on your own. Or maybe you're just like, I don't feel like I'm just going to watch the video. It's up to you. It's your choice. So, let's jump into it. So the first one we're going to do is force 1. It makes sense. It's force 1. Why not do it? And like I said before, we're going to break this up into 2 2D problems. It's a 3-dimensional vector. We can break it up into 2 2D triangles. So the first one of those is going to be calculating the z component and the f prime component of f1. So this is already one of the components down that we need to calculate. And we'll use f prime to calculate the x and the y components. So that's not hard. It is just simply a triangle. We know one of the angles. We know that this is 35 degrees. This is f prime right here. This is f1z right here. That's actually a pretty good z. And this is f1. So since we know what f1 is, this is 250, we can solve for the rest. I will use sine for f1z, as you see they did. And we'll use cosine for f prime. As a note, be very careful about this. Make sure you have your angles right. Make sure that if you're using the full angle to that axis, well, then you don't need a negative sign. But most of the time, you're going to need to add in the negative signs or not add in the negative signs as called for. So make sure you're taking into account what direction everything is going along. Okay. Just make sure I got everything erased here. Boom. Okay, then we can further resolve f prime because it's once again just a second triangle and get the x and the y components. Now, how do we do that? Well, once again, if I'm using the y guy as my bottom, then I have f prime, which is the angle right here, and then f1x right here. And so this would be 25 degrees. That's right angle. This is f prime, which I know now. And this one would be f1x. And this one would be f1y. Okay, so I break those up into components, I can solve for them, and I'm good to go. If we want to, we can then write that in the Cartesian vector form. Adding all the components, being very careful about our sign. So, now we got to solve for f2. f2 is not quite as simple, but it's actually not that hard. Because in the end, you just put cosine of 120, cosine of 45, and cosine of 60. So it's actually really super easy because you know the angles. This is the unit vector right here. This whole thing right here, that's the unit vector. And so you just multiply the unit vector by the magnitude, which is 400 newtons, and you have your answer. It works out really nicely. Okay, so we have both components now. You're like, wait a second, I really expected those angle cosines to be harder. It's not really that hard. Going in the reverse is a little bit harder, but using them is super easy. So if you get it, you're lucky. Just don't forget it, because I promise you, in about 6 weeks, you're going to have completely forgotten Chapter 2. Hopefully that won't be you, but a lot of times it happens to people. Okay, so we have both of our components now. We can then add them together to get our resultant vector right here. Now, we need to get our our direction cosines now. That's what it's asking for us. What are our angles to the coordinate axes? Well, how do we get those? What we do is we take each of these components and we divide by the magnitude of this vector. And then we have to do the whole cosine of theta thing is equal to an inverse cosine. So let's do that. There's a whole lot of math that has happened right here. Let's break it down. So first off, we took the magnitude of a vector, just like I said. And then we said, well, okay, we'll take negative 113.4 and we'll divide it by 485.2. And we'll take the inverse cosine of that. And that's what they did. And so it's 104 degrees to the x-axis. And then they repeat the process for the y-axis and for the z-axis. Now, this is really quick and easy, but just remember that you're going to have to practice it a couple times. Make sure you're walking through the steps. First, you're making this into a unit vector. And then after you've made it into a unit vector, you're taking the inverse cosine of each component of that unit vector to get the angles. Okay, so that's everything it asked for us. So with this problem is done. You have finished it. Well done, you did it. So I hope this makes more sense for you now. I hope that the whole unit vectors, the Cartesian directions, makes a little more sense. Just remember, if you see that projection, that is not Cartesian directions, not angle cosines. Not that. Sorry, not direction cosines. I always want to say it wrong. If you see a projection, it's just a 3D vector that you're going to break up into two 2D triangles. If you see three angles for one vector, and each of those angles goes to its axis, that's where you use the direction cosines. So, hope this helps you, and I'll see all of you next time. Bye-bye.